Alright. Good morning, ladies and gentlemen. Welcome to the webinar series brought to you by the Faculty of Engineering, Environment and Information Technology of Malaysia University in collaboration with IMEKI Students Association. My name is Muhammad Zulhairi and I will become as the moderator for today's webinar session in Malaysia University, and I will be served as your today's session. So before we proceed to our webinars, together with us today is Mr. Technologist Khairul Anwar bin Ibrahim. He is the manager in the Research and Development Department in Bacteria Free Water Engineering, or BACFRE, and a registered professional technologist with the Malaysian Board of Water Technologies. He also registered under the Board of Engineers Malaysia (BEM) and the Institution of Engineers Malaysia (IEM). He received his bachelor degree in mechanical engineering in 2012 from University Malaysia Pahang. He has been working with BACFRE for almost 10 years, began as project engineers, sales and application engineers, and engineering manager. Most of his project is related to the water treatment, specifically in rainwater harvesting system. So without further ado, please welcome Mr. Technologist Khairul Anwar to share his knowledge on the introduction to rainwater harvesting system. Please, sir.
Okay, thank you, moderator, for the introduction. Uh, Good morning to all. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to thank to Masa University for this opportunity to give for us to give this knowledge sharing for all whoever watching this webinar. Okay. Without further delay, I will start my knowledge sharing for today. Okay. Today webinar is regarding the rainwater harvesting system. Okay. I think most of you all maybe did not aware about this system. So today I will going to give you awareness regarding this system. Okay. So basically, my name is Khairul Anwar bin Ibrahim. Okay, for throughout this presentation, so there's a few subtopic that I will share with you guys. Okay, first of all, is a little bit about my company background, just a little bit, and then about the rainwater. Okay, a little bit about rainwater. Okay, and then about product. And then the application that we are going to do. Okay, and then the issue that we are facing during the design stage of designing the rainwater harvesting system. Okay, and then last is the project reference that we have been done throughout the years. Okay, just a little bit for my company. We are established in 82. We are pioneer in the portable drinking water filter. So basically, we are in the water industry, a specialist in the rainwater harvesting system. Okay, this one I just go through to save the time. Okay, so this is our branches in Malaysia. We have Subang, Penang, Johor, and Malacca branch. Okay, so this is about our timeline. Okay, founded in 1982, and then throughout the years we have achieved a lot of achievement. Okay, so we are 40 years in this industry. Okay, so our partner system, Wheezy. Okay, this is so-called we are using Wheezy system, rainwater harvesting system. Okay, founded in 1999. So it's a German brand, manufacturing in German. Okay, this is our founder, system partner. Okay, that a little bit of our company background. Okay. Okay, so for rainwater, understanding of rainwater harvesting system. Okay, for today webinar, I'm not going to go in details about the calculation or design, just an awareness or introduction to the rainwater. So if we are going to do the design and calculation, it will take a full day workshop to master it. Okay, so water is very precious. Okay, so now we have issue like global warming, changes in weather pattern. Okay, so we must reduce, reuse, and retain the water. Why? Why we use the rainwater harvesting system? Okay, so basically most of us knows it. Basically, it's save on water bills. Okay, as a backup water supply. As we all know that who did not know yet, this is a government requirement from the local municipal to have a rainwater harvesting system. Okay, to reduce the chances of flooding and then to protect the environment. Okay, this is the major why we should use the rainwater harvesting system. Okay, so do you know that in 2012, the Malaysia Uniform Building by Law 1984 requires all newly built detached building as well as bungalows and semi-detached bungalows with a roof area 100 meters square and above to be equipped with rainwater harvesting system to capture rainwater for reuse. Okay, so this one is a government requirement for all new buildings. Okay, it's already been gazetted in the Wata Kerajaan. Whoever are interested, and I can say that it's first time that you are hearing this, so you can search in the internet the Malaysian Uniform Building by Laws 1984. Most of the state already uh, gazetted that the new building must install the rainwater harvesting system. Okay, if not mistaken, only Sabah, Sarawak, and Terengganu did not yet to gazette the rainwater harvesting system to be used in the new development. So should be the developers, the architect, or the consulting firm should know that they should have the rainwater harvesting system before they can get approval by the local municipal. Okay, so for the details of the Malaysian Uniform Building by Law, you can search the internet and then you can read through the Wata Kerajaan. Okay, so next, so this one is the so-called that our earliest client during the stage of our development. Okay, so this one is one of our client is an architect. At Bangsa, so he tried to do the experiment to do the rainwater harvesting system for his house. Okay, so if you can see that in the pictures, the pictures only have the gutter, the downpipes, the white downpipes, and then the tank. So without using any pre-filters or any so-called rainwater harvesting system. Okay, throughout the time, a few months, the owner said that the system is working well. So throughout the time, the his pump is a problem and clogged. He asked us to see and then try to investigate what happened once we at his house. So we opened the tank, so you can see that the second pictures, the tank is full of debris, leaves, and then mosquito larvae. Okay, so this is what happened if you not properly design the rainwater harvesting system. Okay, so just a little bit how to design the system. Okay, definitely you need to have the catchment area. Okay, the first one is you need to have the catchment area, because without the catchment area you cannot so-called collect any rainwater. Okay, So the second things is you need to have the rainwater downpipe. Okay, the rainwater downpipe to channel the collect water. And then the third item, most important, is the rainwater tank. Okay, so with the three criteria, so that's what we can call it is a rainwater catchment. Okay, so you need to have these three, then you can collect the rainwater housing system. Sorry, the rainwater. Okay, so there's main criteria. Okay, so catchment area, we have a few design catchment area. We have rooftop, that is a pitch flat rooftop, garden rooftop. Okay, we have podium, we have surface runoff. Okay, road, walkway, garden. So this is that what we call catchment area. So we can collect the rainwater using this catchment area. Okay, do you know that different type of catchment area determines the coefficient? Okay, so this coefficient, you can see that the pitch is 80%, flat roof is 70%, the garden roof is 40%. This coefficient is used during the calculation stage. Okay, so I'm not going to go into detail about the coefficient. Okay, so the rainwater downpipe. Okay, so the rainwater downpipe. Currently, we have two types of rainwater downpipe. Okay, normally the first one is conventional. Conventional means that the normal rainwater downpipe that we see in our house is anywhere. Okay, so the conventional is annual flow. The maximum flow is 30 to 50% gravity, and requires many rainwater downpipe. Okay, so the new challenges that we are having is the new so-called design. There's a siphonic rainwater downpipe. Okay, if you have heard it. Okay, the siphonic rainwater downpipe is a full bore flow. Okay, it's eliminate air in the rainwater downpipe. It has a high velocity discharge and capacity. So the beauty of it, require less rainwater downpipe. So the challenges for the siphonic downpipe, I will elaborate in the at the end of the slide. We have some issue slide. Okay, so this regarding the rainwater downpipe. So two types. So the designer should knows which type of uh, the rainwater downpipe that they are using. Okay, so the rainwater tank. Okay, the rainwater tank, we have a lot of design for rainwater tank. Okay, you can put it a ground level. Okay, ground level water tank. So and then we have you can use it underground water tank. So the underground water tank is a bit costly and highly to maintain. Okay, and then you can put it a high level water tank, so you don't have any required pump. Then you can use it by the gravity flow. Okay, this one is the tank that we should determine where to put it. Okay, so at the bottom, do you know that there are a lot of guidelines how to determine the rainwater capacity. Okay, like the local municipal guideline, DBKL. You have MASMA second edition. Okay, the rule of thumb, and then the GBI Tangki Nari program. So this one is some of the guidelines that people can use. Okay. Okay, so this one I just go through. This one is some of our products. Okay, so we have two types of product. There is one is the for residential, and the other one is for commercial. So different types used for different application. Okay, for this one is our residential. The beauty of our product is the strainer is vertical. Okay, so the leaves or the debris will not stuck easily to the strainer, so it requires less maintenance. Okay, so that the beauty of our system. Okay, I just go through. Okay, so you can see this one is our commercial our commercial product. Okay, you can see that the difference is just the size it. Okay, this one is our smoothing inlet. Okay, so I just go through. Okay, as you can see in the slide, the system, how the system works. Okay, the rainwater, all the debris will not pass through the strainers. Okay, so if you can see that in the video, there's no debris stuck at the strainer. Okay, that's the beauty of system. Okay, this one is our locally designed by the bag free. Okay, this one is for commercial type. And then this one is sort of smoothing inlet. Okay, we have floating suction filter. We have multi-siphon overflow, and then we have the top up valve. Okay, this one is a top up from the local municipal water. So for Selangor, it's Shabas water. Okay, okay. So this one is just a size. Okay, this one rainwater tank. Okay, we have the system. So I'm not going through about the system. So you all just know that there is a rainwater harvesting system in the market. Okay, that we can design. Okay, for application type of development. Okay, you can see that there are, I can say, most of the building can put the rainwater harvesting system. We have a commercial and industrial building, the hotel, the shopping mall, we have public building, we have residential high rise, and we have residential landed. So I can say that most of the building type of development can integrate the rainwater harvesting system. Okay, the usage of the rainwater harvesting system. Okay, with the collection of the rainwater, rainwater can be used for toilet flushing, for general cleaning, vehicle washing, for laundry, for irrigation and sprinkler, industrial application, firefighting reservoir, cooling tower, machine cleaning, and humidification. Okay, I can say that the rainwater have a lot of use. Uh, have a lot of use. So I can say that the project reference at the end of the slide. Okay, so you all can see what we have done. Okay, so water quality. Okay, so this one is some of the I can say that our project that we have been installed. Okay, so every installation that we have done, we are going to take the water sample. Okay, and then we are test in our in-house lab. Okay, so you can see that the water qualities from the three, I can say, three places. There is a Panasonic factory Shah Alam, UiTM Shah Alam, and then the HQ at our office. So actually the water is quite okay, quite clean, but we have no control regarding about the bacteria. Okay, so at our office we have coliform detected. Okay, so that's why if we have the so-called after treatment, if you want to settle this problem. Okay, so we can see that this is the rainwater quality that we are testing in our lab. Okay, so the application. So we go through the issue. Okay, the issue. Okay, so the issue that we are having is the weather pattern and ARI. Okay, so before we design the rainwater harvesting system, we need to see the location of where we are going to install the rainwater harvesting system, because every place have different rainfall and then with so-called weather pattern. If you can see that here is rainfall data for Petaling Jaya Station. You can see that the rainfall is 3,000 mm. Okay, and then for Sepang station, we have 2000 mm. Okay, so that's why when we are designing the rainwater harvesting system, we need to see where we are going to install. So we did not undersize the system and we did not oversize the system. Okay, so this one is one of our project during our early stage of designing at Panasonic factory. So this during this time we did not so-called using the rainfall data to design. So this is what happened. So we just use a small system for a big factory. Okay, so the system is failed. The water is splashed. So we are now for the design we are using the weather pattern and RI. Okay, the second issue is I can say that the siphonic rainwater downpipe system design. Okay, you can see that here as I mentioned earlier. We have issue regarding the siphonic rainwater downpipe because of, you can see that the video. Okay, for the siphonic downpipe, they have high velocity and high flow rate. So that's why we our products or any other product have limitation of the flow rate and velocity. So they need to design according to the rainwater downpipe. So we have a high flow for siphonic. We have high flow issue. So we need to cater to install the rainwater harvesting system. Okay, for maintenance issue. Okay, for maintenance issue. So for the maintenance, we need to do some maintenance to the system. Okay, you can see the video. It's easily to do maintenance. Okay, so when we do the maintenance, and then the system is good to go. Okay, so here we have the testing and commissioning practices. Okay, so after we do the installation, we do some testing and commissioning, and then we have the warranty system. So for any clients or any developer consultant, maybe you need to have the so-called the warranty. Okay, okay, problem with poorly designed system. Okay, so as I said before this, why we need to have a properly designed system. Okay, so as you can see that in the picture, if there's no rainwater filter in your design, so there will be accumulation of the debris in the water tank. You have a full order, you have a breakdown of your rainwater pump, and then you have a mosquito breeding, okay, in your rainwater tank. Okay, so the other one is you have if you have undersized the rainwater system, so definitely your gutter will collapse, and then the water strip at the plaster ceiling, and you have so-called internal flooding. So this one we need to properly design the system. So we don't want this issue to be happen in your so-called building. Okay, this one is for poly design. Okay, undersized rainwater overflow pipe. You can see that there's overflow for the rainwater tank. Okay, so the excess rainwater unable to overflow, your rainwater tank will burst, and also you have the internal flooding. Okay, so be careful with that. And then for the maintenance, okay, so if you don't have proper design, so it's very difficult to maintain your rainwater filter. Okay, so you need to have a rainwater, so your filter need to be maintained throughout the time. Okay, so okay, project references. Okay, so project references. So this one is we are being installed in the SP Setia Corporate Office Setia Alam. Okay, they have using our rainwater harvesting system. They are using for toilet flushing and then for irrigation. Okay, so they want a good quality of water, so they put a multimedia filtration filter, as you can see, and then they also have using the UV system, okay, to kill the bacteria. Okay, so this one is at SP Setia Corporate Office HQ. Okay, so this one is Pertubuhan Arkitek Malaysia at Bangsa at the building. Okay, so they are also using our rainwater harvesting system. Okay, so you can see that the system in the picture at the left side of the picture. So you can see that they are using commercial filter, and then they have first flush system due to requirement by the DBKL, and then they have rainwater tank. Okay, so project references. Another one is at the KDU University College. Okay, at Glamary. So at the right side picture, you can see that they are using the 2 units of filter. The usage of their rainwater is for uh, cooling tower makeup water. Okay, top up water. So the challenges at this, they are using the siphonic system. So later on, I will share you some of our case study at here. Okay. And then the Toyota assembly plant package at Bukit Raja. Okay. They also have the rainwater system, and they have a really big rainwater tank they are using for their production. Okay, for cleaning purpose. And they also using the after treatment, there is a filter, the UF filter, the MMF filter, okay, for their production. Okay, also at Sultan Abdul Halim Muazzam Shah Bridge, Penang. Okay, they are, it's not at the bridge, it's just at the so-called office. Okay, the toll office. They are using underground filter. Okay, at the left side of the pictures. And also IKEA Tebrau. They are also using our rainwater system, the left side, sorry, the right side of the picture. You can see the system. And also Prudential Tower, TRX City at KL, they are using our filter. Setia Penang International Convention Center, SPICE, okay, also using our system. And then the other one is the Setia Ecoglade Cyberjaya. Okay, this one is for residential one. Okay, residential. So this one is Andes Puchong. Okay, they are using for residential. And then the Dahlia Resident Tropicana Aman, also using for residential system. And then Kirara Residence, Garden Residence Cyberjaya. And then this one is some of our project. You can see that Especially Eco World Maseng. Okay. So okay, for I can say that for the residential housing, we have been installed for North 1,000 plus, Center 19,000, South 3,000 plus rainwater harvesting system. So total residential housing that we have been installed up until now is 23,000, okay, units of rainwater harvesting system. Okay, for commercial building, we also been installed total 5,560 units throughout the Malaysia. Okay, that what I can say is that the Malaysia is one of the largest buyer for the rainwater harvesting system, according to our principal Wizi. So we are the largest buyer for the rainwater harvesting system in the whole world. Okay. So this one is some of our projects. Okay. This one. Okay. So I just go through quickly our projects. Okay. So as well, we are office. So anyone who are interested to know more regarding the rainwater harvesting system, or you want us to design for you, you can visit us. Okay. So that's all from me. Thank you. So I will show you.
With the water around us is changing.
Okay, I will show you some video. Hope you enjoy.
The world is changing. Our relationship with the water around us is changing. With record-breaking storms and unprecedented flooding, we are faced with more hostile weather and live on the edge of disaster. On the other end, dams drying up and longer droughts can affect the water supply. As the world changes, those that adapt will thrive. Water is in us, in our bodies, in our lives, in our creations. Our relationship with water has helped define our evolution as people. This is rainwater. It is both a sign of dread and of hope. In our hands, it is the next step in that evolution. Rainwater harvesting technology aims to transform how we see rainwater, because with this technology, rain is no longer just a sign, it is now a resource. It is no longer something to fear, but to use. It is no longer just about life, but about living. So the integration of rainwater harvesting technology is not just the cost of convenience, but the cost of evolution. Because the world is changing, water is changing, we are changing. Are you ready for the next step? So, how does one take the next step? Where does rainwater harvesting begin? Developed in Germany, rainwater harvesting technology begins with filtration. The weather-resistant vortex-fine filter, made of high-grade stainless steel, captures up to 90% of rainwater from the roof's gutters and downpipes, and uses the power of flowing water and gravity to both remove debris and clean itself, relying on the science of centrifugal force without the risk of clogging. The filtered rainwater then enters a storage tank through a smoothing inlet, which allows water to enter in a calm state that would allow both sediment to settle at the bottom and the water to remain oxygenated. The floating suction filter assures that water is extracted from the middle of the tank, where the water is cleanest. The floating suction is then connected to a water pump, which takes the water up and distributes it for use. A multi-siphon overflow with a check valve connects the tank to the drainage system in case the rain does not stop but the storage tank is full. A rain aid valve is installed and connected to the main water supply to ensure that water supply is not disrupted during the dry season. The rain aid operates without electricity. Once the water is pumped up, the water can be further treated and purified using media filters, sediment filters, carbon filters, and then disinfected through a UV system. The water can then move to where it needs to go, from the faucets of a home to the boilers and cooling towers of buildings and factories, to the water supply of fire stations, and even to evacuation centres in times of disaster. With power of rainwater harvesting, toilets waste little in order to save on flushing. The low minerals in rainwater make it naturally soft and excellent for laundry or washing cars. Rainwater is the natural source of water for plants and crops. And rainwater that goes into your storage tank does not flood your streets and saves lives in times of emergency or disaster. When rainwater works for you and not against you, you save up to 50% on your water bills and take your first step towards water independence. Rainwater harvesting technology is here, and rainwater harvesting technology is the future. It is the next step towards water independence. It is the next step in environmental sustainability and green technology. It is the next step in our relationship with water. So, are you ready for the future? Are you ready for evolution? Are you ready for rainwater harvesting?
Okay. That's one. Sorry, Mr. Zul. Can I add on a little bit slide?
Okay, sure.
Just a few slides. Okay. Can I?
Sure. Carry on.
Sorry, yeah. Okay. Sorry. So that's why you can see that this one is one of the case study. Sorry, I missed out this one. Okay, this one is the system we are using at KDU. Okay, KDU. So this one, the few years back we are doing this. Okay, so the location and building type University Shah Alam. So the catchment area is 1,100 meter square. So the usage is cooling tower, top up water, and then the average cooling tower top up water is 598 meter cube per month. And then Shabas water usage for cooling tower is 280. So the rainwater usage is about 300 per month. So at KDU, they have roughly saving about 700 per month. Okay, this one is the data that we are get from the KDU college. Their admin. Okay, so at during the stage of the design, so how they know that how many water they collect. So they are using they are installed the magnetic flow meter after the tank, and then before the top up valve of Shabas water. Okay, so that's why how they know the rainwater usage and then cooling top up water usage. Okay, so this one they are using the BMS system, building management system, and transfer it to their SCADA system. Okay, so this one is the design of it. Okay, sorry for the guidelines. Okay, for the guideline before this, for anyone who are interested in the design, so you can go through first. We have the KPKT design guideline, the books. Okay, from the Department of Irrigation Drainage, Manual Saliran Mesra Alam, Masma Second Edition, Chapter 6. You can go to Chapter 6. Chapter 6 is the rainwater harvesting system. So local municipal guideline, we have a few guidelines from local municipal. So under DBKL, you have this one. So their guideline garis GP2 garis panduan permohonan pelanjalan dan pembaritan. So for British standard, you have the rainwater harvesting code of practice, and then for German standard, you have this one, rainwater harvesting part 1. So anyone who are interested, you can go through to this so-called guidelines, so you can do the design stage. Okay, I think that's all from me.
All right.
I'll go back to the moderator.
Okay. Thank you, Mr. Technologist Khairul Anwar Ibrahim, for sharing with us the interesting topic. So, on behalf of Masa University and the IMT Student Association, thank you also to the audience for finding the time and visiting us today at our webinar session. So, hopefully, this webinar session was beneficial for all of us, and see you on the next webinar session. Thank you, Mr. Carol. Thank you,
Okay,
everybody.
thank you,
And
thank you,
bye-bye.
thank you, everyone.